When delta G value is less than 0, we can say that the reaction is feasible. That is, the reaction can take place. When there are no stoichiometric coefficients present, you don't have to worry about it. If there is stoichiometric coefficient present, you have to take the inverse of it and put it in this form. If you have to calculate the average rate at two different points, how do you do? It is C2 minus C1 divided by T2 minus T1, which will give you the average rate. When the value of rate constant is more, that means the rate of the reaction is also high. Hello everyone, this is Ambli Unnikrishan from the Department of Chemistry, Vidhyaashram School of Excellence, Mysore. So today we are back with chapter 3 of your syllabus, that is chemical kinetics. Okay, so this word chemical kinetics or this branch of chemistry will be a little new for you, right? You might not be familiar with this word chemical kinetics. So let's see what we are going to study in this chapter. Okay, so in today's session, we are going to study about, first of all, what is chemical kinetics, what we are going to study in this chapter, right? And what is this branch of chemistry, what we are going to study, let's see. And then rate of chemical reaction, average rate, instantaneous rate of chemical reaction, then factors on which the rate of reaction depends, okay, dependence of rate on concentration, rate constant of reaction, characteristics of rate constant. All this we'll cover in this session. So first of all, what is that we are going to study in chemical kinetics? So when we talk about chemistry, the first thing that comes to our mind will be chemical reactions, right? So in chemistry, there are a lot of chemical reactions will take place. So how can you determine whether a reaction will take place or not? That means whether a reaction is feasible or not feasible. Okay, so depending upon this feasibility, this word you might be already familiar because you have studied this in class 11 thermodynamics chapter. So feasibility of a reaction, the feasibility can be determined or predicted using thermodynamics. Okay, so when delta G value is less than 0, we can say that the reaction is feasible. That is, the reaction can take place. And when the delta G value is greater than 0, the reaction is not feasible. That means the reaction does not take place. So that can be determined using the thermodynamics branch. Right. Now moving on to the extent of reaction. Extent means what? To what extent the reaction will take place. That means what do we know already? That is reactants combine and form products. Right. So to what extent the product is formed or to what extent the reaction will take place until it reaches equilibrium. So this can be determined using chemical equilibrium. Right. So even this you have studied in class 11. Okay. So these two, that is whether a reaction will take place or not. And the second one, yes, whether it is feasible or not. And the second one is to what extent the reaction will take place. These two can be determined. Now, the third one and the important one is that we are going to study in this chapter is speed of the reaction. That means how fast or how slow the reaction will take place. Okay. So, speed of reaction. That means what? The time taken by the reaction to reach equilibrium. In a way, we can say that. Okay. So, the speed of reaction, how fast or how slow the reaction can take place. So, this chapter, that is, or this branch of chemistry, chemical kinetics, we are going to study about this part, that is speed of reaction. Okay. So, instead of using this word speed in this chapter, you will see this word, that is rate of reaction. Okay, so how the rate of reaction is depending on different factors. What is rate of reaction? All this we are going to study in this branch. Okay, so let's see. Chemical kinetics is the branch of chemistry that deals with the rate of reaction and the factors influencing the rate of reaction. So rate of reaction means, what is it? The speed of reactions itself, right? Okay, so the word kinetics is derived from the Greek word kinesis, which means movement. Okay, and the thermodynamics tells us only about the feasibility, right? So from thermodynamics, you can say whether the reaction will take place or not, right? That can be determined. But how fast or what is the speed of the reaction can be determined using our branch, which is chemical kinetics. So I hope what we are going to study in this chapter is clear for you. What is this branch, chemical kinetics? Also is clear for you. Right. Now moving on to the rate of chemical reaction. So how can you define the rate of a chemical reaction? So let's see. The rate of chemical reaction is the change in concentration of reactants or products in unit time. So you have studied in physics also. How do you define speed? Speed is the change in distance or distance by time. Okay, so coming on to chemistry, what will be rate then? It will be the change in concentration, right? We are talking about chemistry and chemical reaction. So, change in concentration of reactants or products. You can tell in terms of both reactants or products in a given time, okay, or in unit time. So, you can also define as it is the decrease in concentration of reactants in unit time. Why decrease in concentration? Okay, so as time proceeds, what happens? We know that, for example, let's say there is a reactant R, and what happens? Finally, it will form a product P. Okay, so initially when the reactant is starting, there will be a particular concentration of the reactant there. Then finally what happens? The concentration of reactants keep on decreasing, because what happens? It is getting consumed in the reaction. And finally what will be increasing? The concentration of products will be increasing, right? So we can also define it as it is the decrease in concentration of reactants in unit time, right? And also it is increase in concentration of products in unit time. Decrease in concentration or increase in concentration of products in unit time. So I hope it is clear. So how can you write the reaction? Rate is equal to change in concentration of reactants divided by time, or change in concentration of products divided by time. So I hope it is clear. So now let's move on to the graph. As you can see, it is concentration versus time graph. So as time increases or as time proceeds, when the chemical reaction is taking place, what happens to the concentration of reactants? It was initially at this point. Initially there was some value. What happens as time proceeds, as the reaction is taking place, the concentration is decreasing. You can say this graph is for the reactants. Now what happens to the product? Initially, was there any concentration of products? No, right? Initially it is only reactants, there are no products. Now, so what happens from this graph? You can see initially the concentration of product is 0. And as time increases, what happens? The concentration of products increases. So I hope the graph is also clear. So now moving on to the average rate of reaction and instantaneous rate of reaction. Even this you are quite familiar in physics, that is average speed and instantaneous speed of any body. You might be already familiar with this in physics, right? So let's see in chemistry, average rate of reaction. How do you calculate average rate of reaction? So at time T1 if you know the concentration, and at time T2 if you know the concentration, how can you calculate the average rate? So let's see. Let's consider a general equation, R giving P. That is, R is the reactants, P is the products, right? So at time T1, I'm considering the rate of the reaction at 2 times. One is T1 and one is T2. Okay. So at time T1, let the concentration be R1 and P1. R1 is concentration of reactants and P1 is concentration of products at time T1. So it is written in brackets R1. So why it is written in bracket? The bracket, the square bracket indicates the concentration. Okay. So concentration of reactants. Okay. And this indicates concentration of products. So to indicate concentration, you have to put it in square brackets. Right. Now at time T2, what is the concentration of reactant? R2, and concentration of product is P2. Then how can you write delta T? Delta T, what is delta? Delta is change, right? So delta T is final time T2 minus T1. What is delta R? Change in concentration of reactants. It is R2 minus R1. What is change in concentration of products? It is P2 minus P1. Okay. So how can you write the equation? Rate of disappearance of R. Rate of disappearance of reactants. Why disappearance it is written? Because there is decrease in concentration, right? Finally what happens? The reactants will be completely consumed and product will be completely formed, right? So what happens? It is equal to decrease in concentration of R, that is reactants, divided by time. So you can write it as minus delta R by delta T, right? So that means minus R2 minus R1 divided by T2 minus T1. You can write it in this form as well. So another point, why this minus sign is present here? Minus delta R by delta T. Why minus there? As just now I told, it is decrease in concentration of reactants. By decrease in concentration, hence you will put that negative value. Right? Because always once you do the calculation, you will get a negative value. So to neutralize it, that negative and this negative, you will get a positive value. So always when you are writing the equation, there must be a negative sign which has to be used in case of reactants. Now moving on to the rate of appearance of P. Now why appearance? Because as time proceeds, what happened? Yes, the concentration of product increases. So it is equal to increase in concentration of product in a unit time or divided by time taken. That will be equal to delta P by delta T. Okay. So what is delta P? It is P2 minus P1 divided by T2 minus T1. Okay, so I hope it is clear. Now let's take a general equation, that is AA plus BB is giving CC plus DD. So here A and B are the reactants, C and D are the products. Now what are the small a, B, C and D? Those are the number of moles of the reactants, right, and the products. So how can you write the average rate of reaction? It will be equal to minus 1 by A. Okay, so the coefficients of this reactants and products. See, coefficient means the small a, B, C and D. That should be taken in inverse and multiplied with the average rate. That means it will be minus 1 by A. Okay, minus 1 by A, delta A by delta T. It is reactants, that is why this minus sign. And what do you do with the coefficient? This A, you have to take the inverse of that, 1 by A. And this minus sign, because it is reactants, is equal to minus 1 by B. Again it is reactants, right? Minus 1 by B into delta B by delta T, which is equal to 1 by C delta C by delta T. Now why there is no minus sign there? Because it is products we are talking about, right? So you take the inverse of the coefficient, 1 by C delta C by delta T, which is equal to 1 by D delta D by delta T. Okay, so let's take an example here. 2HI is giving I2 plus H2. How do you write the average rate of reaction? It will be, as you can see, it is 2 here. So what do you do with the 2? You take 1 by 2, take the inverse of it. And it is the reactant, so minus 1 by 2, right? Minus 1 by 2 delta, what is it? Concentration of HI by delta T is equal to, right? It is 1 here as well as 1 here. So even if you take the inverse, it is still 1, right? So which is equal to delta of change in concentration of I2 by the time taken divided by change in concentration of H2 by delta T. That's it. Here there is no other coefficients or inverses present because it is already 1 here. I hope when there is stoichiometric coefficients also present, how you can write the average rate of reaction. I hope it is clear. Now moving on to the next one, that is instantaneous rate of reaction. So from the name itself you can say instantaneous. At an instant or at any point in the chemical reaction, you have to calculate the rate of the reaction. Okay, so it is a rate of change of concentration of the reactant or product at a particular instant of time. Okay, so how you can calculate R instantaneous? It is equal to minus dR by dt. As you can see, it is d by dt. Right, instantaneous we are talking. So instead of delta, you will use d by dt. That's it. Okay. So again it is reactant. So minus sign will be there, which is equal to dP by dt. That is d by dt of concentration of products. So I hope it is clear. So for a chemical reaction, if you are taking the general equation, AA plus BB giving CC plus DD, where A, B are the reactants, C and D are the products, A, B, C and D are the stoichiometric coefficients. Again, as we have written in the average rate of reaction, we have to take the inverse of the stoichiometric coefficients. So how you can write, instead of delta, you have to use d by dt here, right? So it will be minus 1 by A dA by dt, okay? Which is equal to minus 1 by B d by dt of concentration of B, which is equal to 1 by C d by dt of concentration of C, which is equal to 1 by D d by dt of concentration of D. Okay. So in here you have to use negative sign because it is reactants. In here it is positive because it is products. So I hope it is clear how to write the average rate and instantaneous rate of a reaction. Okay. So when there are no stoichiometric coefficients present, you don't have to worry about it. If there is stoichiometric coefficient presence, you have to take the inverse of it and put it in this form. Okay. So I hope it is clear. Now moving on to the graph of it. As you can see, this is concentration versus time graph. So at an instant, that means instantaneous rate of reaction if you have to calculate. So let's see what happens to the concentration of reactants. We know that as time proceeds, concentration decreases. So this is concentration time graph of reactants. So let's assume that at this particular point, I have to calculate the rate of reaction. So what you have to do, draw a tangent here and calculate the slope of it. So how do you calculate the slope? It will be minus dr by dt. That is change in concentration by time, right? Okay, y by x, y-axis by x-axis, right? That is how you calculate the slope. So minus dr by dt, which will give you minus slope. So from that, the negative value of the slope, you will get the rate of the, that is instantaneous rate of the reaction. Okay, in the case of reactants. So I hope it is clear. Now moving on to the average rate. So let's consider at concentration C2 and concentration C1. So how do you calculate? Minus delta R by delta T will be C2 minus C1 divided by T2 minus T1. Okay, so this is at 2 times. So at T1 and T2. At T2 the concentration is C2, at T1 it is C1. Okay, so how you can calculate? Okay, using this particular equation. Now moving on to the next one, that is in the case of products, what happens? There is increase in concentration of products, right? Okay, so what happens again? In this case also, instantaneous rate, if you have to calculate at a particular point, you have to take the slope. Okay, so the slope will give you the rate of the reaction, which is dP by dt. Okay, I hope it is clear. There is no negative value here because it is increase in concentration. Same way, if you have to calculate the average rate at two different points, how do you do? It is C2 minus C1 divided by T2 minus T1, which will give you the average rate. So I hope from the graph also how you can calculate instantaneous average rate, it is clear for you. Okay, now moving on to the unit of rate of reaction. Okay, so what did we study about rate of reaction? Rate is equal to change in concentration, right? Change in concentration divided by time. So change in concentration means it can either be increase in concentration of products or decrease in concentration of reactants. So change in concentration, which quantity is present here? Concentration. So what is the SI unit of concentration? It is moles per liter. It is moles per liter. Okay. And what is the SI unit of time? It is second. Okay, so if I am taking the second to numerator, and here what is mole per liter? How can I write? Mole liter inverse, right? This is per liter, so I can write it as liter inverse, and this second, when it is taken to numerator, that also becomes second inverse. So what is the unit of rate of a reaction? It is mole liter inverse second inverse. Okay, so this is the unit of the rate of reaction. So as you can see here, mole per liter, that is unit of concentration, divided by unit of time is second. So what will be the unit of rate of reaction? Mole per liter per second, or else you can also say it as mole liter inverse second inverse. So I hope it is clear. Now that is the unit of rate of reaction. Now moving on to the different factors on which the rate of reaction depends. So first one is nature of the reactants. Okay, the second one is concentration of reactants, then it is temperature, pressure, effect of catalyst, and influence of radiation. So all this in detail we are going to study in here. So you have to remember all these factors which is affecting the rate of reaction. So this is important. So let's we are going to study in detail about each of this in this chapter. So first let's see dependence of rate of reaction on concentration. How on concentration? How in change in concentration depends upon the rate of reaction. Okay. So the rate law, okay, rate law, which is important. The rate law is the expression in which the reaction rate is given in terms of molar concentration of reactants, with each term raised to some power which may or may not be equal to the stoichiometric coefficient of the reactants in a balanced chemical equation. Okay, so this sentence might be a little long. So let's see how you can write the rate law. So what is actually the rate law? Rate law gives a relationship between rate of the reaction and the concentration of the reactants, not products, only the reactants. So if I am considering a general equation, okay, so how you can write the rate law? As I told you, it's a relationship between the rate of the reaction and molar concentration of the reactants. Okay, so you can write rate is directly proportional. Okay, the rate of the reaction will be directly proportional to the molar concentration of A and B. Okay, A and B both are reactants, right? Raised to the power which is equal to the stoichiometric coefficients. See here, what are the coefficients? A and B. So A raised to A, B raised to B. So this is called as the rate law or rate expression. Okay, so to remove this proportionality, you can put a constant here K which is called as the rate constant. So I hope it is clear. Okay. So one point that you have to always remember here is that the A and B which is written here, which is the stoichiometric coefficients of the reactants, it can be or cannot be equal to the stoichiometric coefficients. So that is why you can see here, even though it is A and B here, it is written X and Y. Why? Because it can be equal to A and B and it cannot be equal. Okay. So as it is written here, which may or may not be equal to the stoichiometric coefficient. Right. Always it will not be equal to the stoichiometric coefficient. So this is the rate law or rate expression. So how can you write it? Rate is directly proportional to the concentration of the reactants raised to the power which is equal to their stoichiometric coefficient or may not be equal to. So in general, you can write instead of A and B, you can write X and Y. So, okay. So to remove the proportionality, there is a constant which is introduced that is called as the rate constant, which is also important. So how can you write? Rate is equal to K into A raised to X into B raised to Y, and where K is called as the rate constant. Okay. So the equation which relates rate of the reaction to the concentration of the reactants is called as the rate law or rate expression. So it relates between the rate and the concentration of reactants. So I hope it is clear. So again, I am mentioning this X and Y and A and B can be equal, cannot be equal. Okay, it will not be always equal to the stoichiometric coefficient. Now continuing this, rate is equal to K into A raised to X into B raised to Y. We have already studied this. And we also know that rate is equal to minus d by dt of concentration of reactants. That is instantaneous rate. From this, we have already studied this equation. Just now we have studied it. So instead of rate, you can write this equation. So what can this be equal to? Minus dr by dt will be equal to K into A raised to X into B raised to Y. So now this part, this equation is called as the differential rate equation. See why it is the differential rate equation? Because d by dt is here. Minus d by dt of r is equal to K into A raised to X into B raised to Y. So this is called as differential rate law or differential rate equation. Now what is rate constant? How can you define rate constant then? Rate constant is the rate of reaction when molar concentration of reactants is unity. That means rate is equal to, what did we study? K into A raised to X into B raised to Y. Right. So if both of the concentration is 1, what happens? This will be K into 1 into 1. Right. So 1 into 1 means it is 1 itself. So what happens? Rate will be equal to K. So how can you define K then? That is rate constant will be equal to the rate of the reaction itself when the concentration of the reactants is unity. So I hope it is clear. Okay. So this is differential rate equation. So now let's take few examples here. So the first equation is 2NO plus O2 gives 2NO2. So how can you write the rate law or rate expression? Rate will be equal to, see, you can also see the rate is expressed by the symbol small r. Okay. R is equal to K into, K is the rate constant, into NO raised to 2. So this is the stoichiometric coefficient raised to 2 into O2. As you can see here, there is no other coefficient here. That means it is 1 and it is O2 raised to 1. Okay. So this is how you write the rate law or rate expression. So do I have to consider this part? No. It is the rate law or rate expression is a relationship between rate and the concentration of reactants. Okay. So R is equal to K into NO raised to, this 2 will come in the power and here the 1 will come in the power. Okay. So as I told you, it's not always equal to the stoichiometric coefficient. So let's take another example. Chloroform, CHCl3 is chloroform, reacts with chloride to give carbon tetrachloride and HCl. So this is the reaction. So actually what is supposed to be the rate here? K into molar concentration of chloroform raised to, there is no powers here. So 1 into molar concentration of chlorine raised to 1. This is supposed to be the rate of reaction. But what it is, as I told you, the stoichiometric coefficient is always not the powers which is used. Right. So as you can see here, instead of 1, it is 1 by 2. So as I told you, the A and B and X and Y can be equal, cannot be equal. So in this case, as you can see, how it is depending, it is raised to 1 by 2 here. Same in this reaction also you can see. This is CH3COO C2H5, which is an ester. It reacts with water to give acid and alcohol. This is the reaction. So as you can see here, the rate is equal to K into rate constant into molar concentration of the ester raised to 1 and molar concentration of water raised to 0. As you can see here, it is depending on the concentration of the ester, but it is not depending on the concentration of water. It should be H2O raised to 1, right? As you can see, it should be H2O raised to 1. But it is not depending on the concentration of water. Okay, so what are these types of reaction? All this in detail we are going to study in the upcoming sessions. But as of now, I hope you understood, that is, the stoichiometric coefficients will not be always equal to the powers. Okay, even though it was 1 and 1 here, it does not depend only on the concentration of water. That means it only depends upon the concentration of ester which is taken and not depend upon the concentration of water which is taken. Okay, so I hope it is clear. Now the characteristics of rate constant. Okay, so on what factors the rate constant is depending? That is the K. Okay, let's see. It is a measure of rate of reaction. Higher the value of K, greater is the rate of reaction. So when the value of rate constant is more, that means the rate of the reaction is also high. Okay, a particular reaction has a definite value of K at a particular temperature. So each reactions will have different K values. The rate constant will differ for each reaction and it depends on temperature also. Okay, so each reaction will have a particular rate constant at a particular temperature. When you are changing the temperature, the rate constant also changes. Okay. Now the value of rate constant increases with increase in temperature. So this is very important. Yes, the rate constant increases with increase in temperature. Okay, so the rate constant do not depend upon the concentration of the reactants. It only depends upon the temperature. Okay, now it does not depend upon the initial concentration of reactants. Okay, and its unit depends upon the overall order of reaction. Okay, so what is order of reaction and how this unit is changing depending upon the order of reaction, we'll study in the next session. So what you have to remember here, when the rate constant is increasing, the rate or the speed of the reaction also increases, and the rate constant is directly proportional to the temperature, right? When temperature increases, rate constant also increases, and the rate constant do not depend upon the concentration of the reactant. So these 2 points are very important. So I hope the characteristics of rate constant is also clear. So in the next session, we are going to study what is order and molecularity of reaction, and then we are going to study integrated rate equations, which is very, very important. So I hope what and all we have discussed in this session is clear for you. So that's all for today. Thank you.